Differentiation. Now, there are a few things that we need to review, but remember the derivative is finding out the gradient at a particular point as well. So a few rules that we should already know, but if we've got a constant and we differentiate it, we get 0. We get x to the power of n. Remember, take the power at the front. There's our n. X to the n minus 1. We'll take away 1 from the power. Sine becomes cos. Cos is a negative sine x. E to the x is still e to the x, and log e of x becomes 1 on x. The product rules is one way that it's written, and then the other way. So there's two ways that it's written. Just remember, it's the first one differentiated, leave the second one as it is. It's the second one differentiated, leave the first one as it is with the plus. The only difference between this and the quotient in the numerator section is just instead of a plus, we have a minus, and then we've got h squared. And there's another way of writing it. And there's the chain rule when we have a function inside another function. So we differentiate it. So we've got h dash of the g of x, so that stays the same, and then we differentiate the inner function as well, and that's the other way of writing that one as well. Example 1, differentiate each of the following with respect to x. So I'll do this one properly at the moment. This is a times in the middle, so we're going to use the product rule, but we'll first better say let y equals the square root of x sine of x. You can put the dot there for the times, you can put a times, it's up to you. Then we're going to do y, I'll change it to f of x, then f dash of x. So that's x to a half. Differentiating that, I get a half x to the minus a half. And differentiating sine becomes, and leave the other one, leave sine x. Then plus, differentiate the sine, I get cos x, and leave the square root of x as it is. So this is down the bottom to become, so I get 1 on 2 square root of x times sine x plus square root of x cos x. And you can leave it like that, you can write it as one fraction, it's entirely up to you. B, we got 1 divided by another 1. So this is the same rule. First one, I'll just say let y f x equals x squared divided by sine x. It doesn't matter if you use y, but I'm going to try and keep it consistent with functions. F dash of x. Now I'm going to do the rules all together in my head. So differentiate the top one, so 2x. Leave the bottom one times sine x. Now remember the difference between these ones is there's a minus. Now leave the top one, so x squared. Differentiate the bottom one, sine. Differentiated because cos. All divided by sine x, and that is squared. So I'm just going to put the squared there. And of course, if you can simplify, you can simplify it. If not, let's just leave it as it is. That was part B. This was part A. Part C, cos x squared plus 1. I'll make that equal f of x. So there we go. Now again, this is a product of a function and a function. So I'm going to differentiate. So here it is, f dash of x. I differentiate inside. So differentiating the inside the brackets, I get 2x. Okay. Then I've got to differentiate cos. When I differentiate cos, I get negative. There it is there. Sine, and inside the bracket stays as it is. Now you can do it the whole way. So let me just write that better. You can do it the long way. That's just a product. You can say x, let u equals x squared plus 1. All right, and you're differentiating u to y dx, du dx, and then you've got dx du. It's up to you. Try and find shortcuts to help you. The derivative of tan kx is, we put the k at the front, and then we go sec squared of kx. So that's very important. So we're differentiating this, and we got k, and then we've got sec squared of whatever that was, kx. Example 2, differentiate each of the following with respect to x. So here we go. Again, I'll say f of x equals tan 5x squared plus 3. So differentiate inside the brackets for f dash of x. So I get 5x squared. Differentiating that, I get 10x. There it is right there. Then the tan becomes sec squared, and leave the inside the brackets 5x squared plus 3. So there's my answer to part A. Part B. Again, I'll say f of x equals tan cubed of x. Now, if you want, you can do this, separate. It is up to you. Again, you don't need to. F dash of x. Now, this is the cubed, so that's just like u cubed. So if I differentiate that, I get 3u, which is tan squared x. And then I've got to differentiate my tan, which becomes my sec squared x. So there's that answer there. And part C, again, I'll say f of x equals sec squared of 3x. Now this is a little bit harder, so I'll change that to y actually. Okay, so then I get, using the Pythagorean identity, that this becomes tan squared of 3x plus 1. I don't expect you guys to know that, so I'm going to differentiate that one there. So y dash or equal, now differentiate the tan squared, so there it is, 2. Differentiate inside the bracket, so that's 3. I've still got my tan, because when I differentiate that 2, I still get a power of 1, so I still got my tan 3x, there it is there. And tan differentiated becomes sec squared of 3x. So this is just 6 tan of 3x sec squared of 3x. Now you can do the whole thing again. I'm just finding shortcuts for you. If you understand them, it's great. Now there's different ways that we can write derivatives. So here, example 3 says find e dx of x squared plus 2x plus 3. So this will just equal differentiating the x squared becomes 2x, and this becomes plus 2. This one, well, that's just e to the u. So if I differentiate the u, I get my 2x. There it is there. I've still got my e to the x squared. So there's that one there again. You can do all the steps. And differentiating sine squared z. So I'll differentiate the 2. There it is. I've still got and differentiate my sine squared. So I've got sine of z. Still got that. Then I've got to differentiate sine. The derivative of sine is cos z. Now this is just the double rule. So we've got 2 sine 2z. Now the derivative of log e mod x, we're going to find this. Now remember that here, right, doesn't touch. So I've just done it all for you already. So d dx of log e mod x for x not equal to 0. If we let y equal log e mod x, and if x is greater than 0, then we get y equals log e of x. Differentiating that, we get y dx equals 1 on x. If we consider when x is less than 0, we've got log e of negative x, and differentiating that gives us 1 on x. So it's the same thing. Part B, d dx of log e mod of sec squared. Well, sec x. Sec x is just 1 divided by cos x. So we're going to differentiate mod of 1 divided by cos x, which becomes negative log e of cos x, because when... Alright, then let u equal cos x. We get y equals negative log e of u. Again, you don't need to use these rules. So derivative of that one becomes negative 1 on u. Derivative of cos becomes negative sine x. 2 negatives become a positive sine x, but u is cos x. Sine x divided by cos x, which is tan x. And here is just the rule for it. So when you've got log e of mod x, you can just find the derivative by doing 1 divided by x.